students. Now we are dealing with the family Fabaceae. Most of the plants belonging to these families are trees, shrubs or herbs. So what I have got is a small herbaceous plant. Nodri the herbaceous plant. Okay, it is not a huge tree or a shrub. Stem is so weak. So such kind of stem we call it as a climber. It is a climber. Okay, in most of the cases a stem might be woody or which belongs to tree or shrub. So leaves are arranged alternatively. One from each node leaf arises in alternative. See, now it arises at left, other time it arises at the right. Okay, if the leaves are arranged in this fashion, we call it as alternate. So these leaves are pinnately compound. You can see how the leaf is dissected, or else if the leaf was simple, it would form only one leaf. So now the leaf has been incised in such a way that incision of the leaf are touching the midrib and they are going to give rise to a leaflet. So for this entire thing we call it as a leaf, and these green structures what you are seeing, they are known as leaflets or pinna. Okay, so such kind of leaf we call it as a pinnately compound leaf. ಇದಕ್ಕೆ ಏನಂತೇವೆ ನಾವು pinnately compound leaf. But ಈ family ಒಳಗಡೆ it's not that only pinnately compound leaf will be there. Even some plants are going to possess simple leaf too. Okay, now what you are seeing is a pinnately compound leaf. Another distinguishing character of this family, wait a second, I'll rotate it. Okay, another distinguishing character of this family is pulvinous leaf base. You can see the base of leaf is pulvinous. It means leaf base is swollen. ಈ swollen structure ಗೆ ಏನಂತೆ ನಾವು pulvinous leaf base. Okay, so if I slowly rotate this way, we can also find a stipule over here. I'll just focus it out. See, small leaf like structure at the base of leaf. Can you see? This is nothing but a stipule. Okay, if it is present at the base of flower, we call it as bract. If it is present at the base of leaf, we call it as stipule. Okay, now I think so it is present at the base of leaf, so it is a stipule. So because pedicel is here, flower. Okay, understood? So most of these leaves are going to bear a stipule, so we call these leaves as stipulate. And coming to the venation, how the veins and veinlets are arranged. Okay, all these are network kind of branching. So when veins and veinlets are arranged in a network fashion, we call it as a reticulate venation. Okay, now we are going to study some floral characters. Floral character andre the characters of flowers. Okay, vegetative character means the character of root, stem, leaf. You know vegetative characters anta helteve. Now we are studying the floral characters. Okay, now firstly coming to the inflorescence. How the inflorescence is? Inflorescence is racemose. Nodri hanga the larger flower or the older flower is at the base. When you go at the apex, okay, here I am focusing out. This is a bud. This is a flower bud. Okay, ಇದಕ್ಕೆ ಏನಂತೇವೆ ನಾವು ಈ ರೀತಿ ಇದ್ರೆ we call it as racemose inflorescence. When the buds are at the apex and at the base you find the older flower, racemose inflorescence. Next coming to the flower. So while we dissect out this flower, we can see that flowers are bisexual. Bisexual andre it will be having both stamens as well as pistil, or androecium as well as gynoecium. ಇದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೇವೆ ನಾವು ಫ್ಲವರ್ಗೆ bisexual ಅಂತ ಹೇಳ್ತೇವೆ. ಆಯ್ತಾ? So before dissecting it out, we'll study some character features. Okay, after dissecting I'll show you how the flower is bisexual. Now we are going to study the zygomorphic nature of flower. So students, I am using a blade. So in such a, see, now we are going to study the symmetry of the flower. That is, this flower is zygomorphic. It means through this blade I can cut this flower vertically, so that this vertical plane should pass through the center of flower. So when it passes through center of flower, it gives two equal halves. Nodra ಎರಡು equal half on the left side, other equal half on the right side. If I cut like this, no, it won't give. In any angle, if I cut, it won't be giving two equal halves. So when I cut this flower through only this plane, this exact plane, I'll be getting two equal halves. So we call such flower as zygomorphic. Okay, now we'll study regarding sepals. Okay students, what green color part you are going to see? ಇದೇನು ಗ್ರೀನ್ ಕಲರ್ ಕಾಣತ್ತಲ್ಲ, ಈ ಪಾರ್ಟಿಗೆ ಕೇಲಿಕ್ಸ್ ಅಂತಂದು ಹೇಳ್ತೇವೆ. ಇಂಡಿವಿಜುವಲ್ ಮೆಂಬರ್ಸ್, ಇಟ್ ಮೀನ್ಸ್ ಕೇಲಿಕ್ಸ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ 5 sepals. ಸೊ ವಿಲ್ ಕೌಂಟ್ ಇಟ್. ಓಕೆ, 1 2 3 4 and 5. Okay, 5 calyx are there. See, when these calyx are fused, ಈ calyx fuse ಆಗ್ಯಾವ್ರಿ, ಬರೀ ಮೇಲ್ಗಡೆ ಎಷ್ಟು ಓಪನ್ ಐತೆ, ಹೌದಾ? ಸೊ majority of the calyx is fused. So we call this condition of calyx as gamosepalous. Gamosepalous ಅಂದರೆ fused calyx. Calyx are fused. ಫ್ರೀ ಇದ್ದಿದ್ರೆ ಹೆಂಗಿರ್ತಿದ್ವು, ಕೆಳಗಿಂತ್ರ ಮೇಲ್ಗಡೆ ಫ್ರೀ ಇರ್ತಿದ್ವು. ಬಟ್ ಹಿಯರ್ ನೋಡ್ರಿ, ಬೇಸ್ಲಿಂತ್ರ ಇಲ್ಲಿ ಮಟ್ಟ ಫ್ಯೂಸ್ ಆಗೈತೆ, ಬರೀ ಇಲ್ಲಷ್ಟು ಫ್ರೀ ಅದ. ಓಕೆ, ಸೊ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅನ gamosepalous, or when calyx are fused we call it as gamosepalous. Next, coming to aestivation. Okay, I think you people have studied aestivation. Okay, so aestivation means how this calyx or corolla, they are arranged in flower bud condition. How they are arranged. Okay, now this is a flower. So whenever we are studying aestivation, we should usually study in flower bud. So now we can't study in calyx also. See, here usually calyx has opened up, only we can study it is in a ಕರೋಲಾ ಒಳಗಡೆ ನಾವು ಎಸ್ಟಿವೇಷನ್ನ ಕಲಿಬಹುದು. ಬಟ್ ಇನ್ ದಿಸ್ ಫ್ಲವರ್, even after opening of the flower, estivation is clear and distinct. So we shall study the estivation here itself only. Okay, usually we study estivation in flower bud, but even after the opening of flower also you find estivation exactly how it is in flower bud. ಅದಕ್ಕಾಗಿ ನಾವು ಫ್ಲವರ್ ಒಳಗಡೆ ತಿಳ್ಕೊಳ್ಳೋಣ estivation. ಸೊ ಸ್ಟೂಡೆಂಟ್, estivation ಹೇಳ್ತೇನೆ ನೋಡ್ರಿ. ದಿಸ್ petal, what you see, this is a large standard petal. Okay, which is enclosing 2 wing petal. ಇಲ್ಲಿ 2 wing petal ಅದ. Okay, after dissecting, I'm going to dissect it out and place them separately. You can understand. ಈ 2 wing petals ಅನ್ನು ನಾವು ತೆಗೆದು ಬಿಟ್ರೆ, when we open them out, we find 2 keel petals within them inside. Okay, now I'm going to dissect out these petals and explain you neatly. See, when petals are free from base to the tip, this condition we call it as polypetalous. See, petals are not fused. Okay, only sepals are fused, so we call that condition as gamosepalous. But when petals you can separate them out, this condition is called as polypetalous. So I will open one by one all 5 petals. See, one I have opened standard. Now we have left with this 2 wing petals. See, 2 wing petal open madidre, you can also see a keel petal over here. Can you see keel petals? Okay, which is enclosing gynoecium and androecium. Okay, I'll open it out, wing petal. So students, now you can see this is a standard petal, 2 wing petals. Now I am taking out keel petal as they are slightly fused. Now I am going to open this out, keel petal, as they are slightly fused at the apex. They are enclosing gynoecium and androecium. Now you can have a clear cut view of keel petals. They are fused at the apex and at the base they are free. Now I am going to dissect them out and keep them. Okay, now we can see within this keel petals. Okay, standard 2 wing petal and 2 keel petals. Now I have dissected out. Within keel petal you can find the androecium, which has formed 2 bundles. So we call it as diadelphous condition. Okay. Okay students, so now we can see how anthers have been formed into 2 bundles, that is diadelphous condition, in 9 plus 1. So we shall count the number of anthers. During dissecting, some anthers have come out. 1 2 3 4 5 6 7 8 9. Okay, these all 9 anthers are going to form one bundle, and this is forming another bundle, this one anther. So we always represent them as 9 plus 1. So within this you find a gynosia, which is green in color, that is gynosia. This is how the gynoecium was enclosed within this one bundle of androecium. Okay, this is one bundle of androecium, this is another bundle of androecium. All together they were enclosing this gynoecium. So you can clear cutly see how the stigma is. This is stigma, this is style, and this is ovary. Okay, here 9 stamens have been fused to form one bundle. One stamen is free to form the another bundle. So this is diadelphous condition of stamen, and this is pistil. So which is monocarpellary. When we dissect out or when we section it out, we can see one locule one locule in a clear cut way. And ovary is superior. So before dissecting it out, we saw that this ovary you can clear cutly see. From the base of the ovary, anthers have been originated, or androecium has been originated, or corolla or calyx, all have been originated from the base of ovary. So ovary is monocarpellary, only one carpel is there with superior ovary, and it is having marginal placentation. So this is how stigma, style, and ovary looks. Later after fertilization, this ovary develops into a fruit. See, now only it is slightly resembling like a pea. Have you eaten pea? Okay, the fruit of pea is resembling. So this fruit we call it as legume or pod. So within this fruit many ovules will be there. So within this ovary many ovules will be there. Ovary develops into fruit and ovules develop into seed. You can just have a look of marginal placentation, how the ovary looks. So this is the wall of ovary attached, to which ovules are attached. You can see one ovule attached to the wall of ovary. So as I have took it TS, it appears this way. You can also go for a longitudinal section to have a clear cut view of marginal placentation.